So the 2024 mock question 4 from the paper 2 is on trigonometry. Okay, so as soon as we see triangles with angles in them, we're pretty much looking at trigonometry. If we go to the trigonometry section of our log tables, okay, so literally where it says trigonometry up here, the page that we look at most is this 4th page of trigonometry of the triangle. So that's what comes up most in ordinary level maths. So here are a load of formulas that we're more likely to use. So our SOHCAHTOA, our theorem of Pythagoras, cosine rule, sine rule, and the area of a triangle. So here, the first question says, the lengths of the sides of a right angle triangle are as follows, with the angle beta indicated. Evaluate as a fraction the sum sine beta plus tan beta. So we know that, as we've just seen here, okay, the sine of the angle is, so this sine A is A over C. Now, we know that as this part of SOHCAHTOA. Okay, so if we are looking at SOHCAHTOA here, okay, it wants the sine of the angle and tan of the angle. So just looking at the sine of the angle part. Okay, the sine of that angle, and you can call it angle X or whatever, you don't have to keep with that weird Greek B. Okay, if you want, you can put in X, A, theta, whatever you want. Okay, and it's the opposite over the hypotenuse. Okay, so that is the sine, and then the tan of the angle is the opposite over the adjacent. Okay, so looking at the triangle that we are given here in this question, so here is where my angle is, the beta part. Okay, the hypotenuse side is always the side opposite the right angle, so that is H. Opposite the other angle, so beta in this case, is the opposite side, and then the last side that we have left is our adjacent side. Okay, so they have asked for sine beta plus tan beta. Okay, so I don't have a lot of space here to do this one out, so I'm just going to do it out over to the side. Okay, so we have sine beta plus tan beta, and we have just figured out how to write those as fractions. Okay, so I can write that as the opposite over the hypotenuse plus the opposite over the adjacent. Okay, so I can just fill that in from what I have in the triangle. So my opposite side was 3 over my hypotenuse 5. And then again, my opposite side is 3, and over my adjacent now is 4. Okay, so put that into your calculator and we will get that it's 27 over 20. Okay, so that is part A. It seems quite long the way I went down through it. I'm just trying to show you where I'm getting every single thing from. Okay, remember, if there is something like this that's taking up more space, just write in a little note in the box, like go to back page, and then on the back page, make sure it is very clearly labelled question 4A. Okay. 4B then says a piece of string is placed on a table. I'm going to come back to what that is. A triangle. To form a triangle. P, Q, or. The length from P to Q is 5 centimeters. Okay, so they filled that into the diagram. And Q to or is 9 centimeters. They also filled that into the diagram. The area of the triangle is 13.71 centimeters squared. Okay, so find the angle P to Q to or to the nearest degree. Okay, so remember the angle P, Q, or is the angle that's made when we go from P to Q to or. So this angle here. Now, I'm going to call that angle A, because in most of the formulas in the log tables, that is what they are calling the angle. Okay, so the angle is A in all these. So I'm going to look through this and I'm going to see, okay, so they gave me the area of the triangle. So how am I going to manage to relate that back? So look here, the area of the triangle they've given me as half AB sine C. Okay, so AB sine C. So look at where A and B are. They're the sides touching that angle C. Okay, not the opposite side, the two sides connected to it. So I'm going to write down my formula. Okay, so part 1 of B. So the area, and I'm going to write out area is equal to, just so I don't get it confused, if I write A as the angle A. Okay, and it's half. And look at the way the letters are. It's a small a. Okay, small b, sine, and then a capital C. So we know that the small letters represent sides, and then capital letters represent angles. Okay, so in this triangle here, if we are looking at this angle A here, okay, that actually is, if we are trying to find that angle and we are looking at this formula, where would that formula end up filling in? Well, it would be this sine C part. Okay, so here, this A is just the angle. So from this formula here, the angle that we probably should call that to avoid confusion is this angle C. Okay, so it doesn't matter again what you call that angle. Let's just, once we figure this out, let's just say that that's angle C instead. Okay, if that's angle C, then the side opposite it is small c, and then the other two sides are sides A and B. So we have small a, small b, and we have the area. So in this equation here, the only unknown is this angle. So I'm going to fill in this equation, okay, hopefully fill in one thing correctly so that I can get the 2 out of 5 marks. If I manage to fill it fully in correctly, I'm getting 3 out of 5 marks. And then if I manage to try and rearrange something to do with it, I'm getting 4 out of 5 marks. Okay, so look at this and fill in what you know. So they told us that the area of the triangle is 13.71 centimeters squared. So 13.71. Okay, and that was equal to a half times A times B. So A there is 5 centimeters. B is 9 centimeters times sine C. Okay, so we need to get C on a side by itself. Before I try and move things across, I'm just going to simplify both sides, just so that it makes it easier for it to rearrange. So I'm going to get 13.71 is equal to, okay, and then I can do a half times 5 times 9, so that I get 22.5 times sine C. Okay, so we want C by itself, so we are going to get rid of the 22.5, that's multiplying sine C. Okay, so get rid of that by dividing, because it was multiplying. Okay, so we need to divide by 22.5, so that the 22.5 that's multiplying and dividing cancel. So I'm going to get 13.71 divided by my answer, which was 22.5. So that I get 0.6093 recurring. So because when I've put this into my calculator, I'm getting something that's recurring, it's actually more accurate for me to just leave it as a fraction, okay? Otherwise, I'm going to have to end up rounding a decimal. So I'm going to actually leave this as the fraction, 13.71 over 22.5, so that I'm not rounding it, okay? And that's what's going to be sine C. Okay, that's not giving me C though, it's giving me sine C. So how do we get rid of that sine part? Well, we do the inverse sine. Okay, so I'm going to do the inverse sine there to basically undo this sine part. Okay, so if I do the inverse sine then of the answer that I just had on my calculator, I'm going to get 37.5 5, 4, 1, 3, 1, 4, 2, 2. So to the nearest degree, it is 37.54 degrees. Okay, so to the nearest degree, it's going to be 38 degrees. Now, is what C is. Okay. Yeah, so then the next one says find the length of the side P or to the nearest centimetre. Okay, so find the length, okay, of the side, and then technically that's the length of P to or. Okay, so they are just still giving you that hint there. So we now know this. What can I get rid of? I'm going to get rid of all this part here from part A, just so I can draw out a little sketch of this triangle that we have. So we have P, Q, and or. We have this side, and we now have this angle of 38 degrees. Okay, what they are now asking us to find is what is this third side. Okay, remember we are looking at trigonometry. If you look at the log tables, okay, it's going to remind you of the rules that we can choose from here. These rules are Pythagoras' theorem and our SOHCAHTOA are right angle triangles only. Okay, these rules here, our area rule, our sine rule, our cosine rule, they work for all of our triangles. So there is nothing in the question to say it is a right angle triangle. We have to assume we are working with one of these. Okay, now we've just used the area formula. The sine rule, you can ignore one part of this. Okay, it's always using two small letters, two capital letters. Okay, a small letter and the same letter as a capital, and a small letter and the same letter as a capital. So the small letters are two sides, the capital letters are two angles, and they're the opposite ones. Okay, so small a is opposite capital A, small b is opposite capital B. Okay, so that is two sides and their opposite angles. The cosine rule uses three small letters, A, B, and C. Okay, so every side of the triangle, and a capital letter A. So it's using three sides and one angle. That is what I have here. Okay, so including my unknown, I have three sides and an angle. So that means that I'm going to use my cosine rule. Okay, so A squared is equal to B squared plus C squared minus 2BC cos A. Okay, and the fact that that angle there is A is going to determine how we choose our sides, what letters we are going to choose them to be. Because the angle that this uses is called A. Okay, and the capital letters have to be opposite the small of the same letter. Okay, so this side here, my question mark side here, has to be small a. Okay, doesn't matter about the other angles, so I can just call them B and C. Okay, so question B part 2 is using the cosine rule. So it's telling me that A squared is B squared plus C squared minus 2BC cos A. Okay, so we need to fill that in. So A squared is my unknown. Okay, everything else, B, C, and the capital A, so the angle is everything we can fill in. So again, here we have an equation. It only has one unknown, so that's perfect. That means that I can find my unknown. So I'm going to get A squared is B squared, so 5 squared, plus C squared, so 9 squared, minus 2 times B times C times the cosine of the angle A, so 38. Okay, what I was going to say over here, and I'm now remembering to say over here as well, make sure that your calculator is on the mode for your angles to be in degrees. Okay, so press shift and then the button that says mode setup. Okay, so that you go into setup and then the number 3 there is for degrees. Okay, in ordinary level maths, we are only looking at degrees, so that is the setting that your calculator should be in. Okay, luckily here on the right hand side, we know everything. We have no unknowns on the right hand side here. So we actually can go straight to typing the full right hand side into our calculators if we want. Okay, or you can do it out so that you say that it's 25 plus 81 minus 90 cos 38. Okay, do not make the mistake of thinking that you can take this 90 away from over here. Okay, this is like a bit of algebra. This minus 90 is connected to the cosine 38. Okay, so if this was something like 25 plus 81 minus 90x, you would not be able to take that 90 away. Okay, it's the exact same situation here. We can add the 25 and the 81, but that minus 90 has to multiply the cosine 38 first. Okay, it has to multiply. With BIMDAS, we know we have to do the multiplication part before we add it on. So, I'm just going to type it onto my calculator now. So 25 plus 81 minus 90 cos 38. And we get 35.0790318. Okay, that's a lot for me to write out, but I'm just going to write out the start of it. So I'm going to write out that it's 35.079. And then when I square root in my calculator, I'm going to, instead of just typing in the square root of 35.079, I'm going to click the square root and then I'm going to click that answer button beside the equals so that it's actually typing in every decimal that would have continued on to give. My answer there is going to be 5.92275. Okay, and it says to the nearest centimetre, so I'm just going to round that up then to 6 centimetres. Okay. The question then goes on to a part C that says a lighthouse L is observed from a ship sailing in a straight course due north. The distance from A to B is 3 kilometres and the bearing of the lighthouse from A is north 42.7 degrees east. The distance from B to L is 2.93 kilometres. So, find the angle ABL to 1 decimal place. So A to B to L is this angle here. Okay, now they've kind of given you like a bit of a trick in this one because we have, if we are looking at it, including our unknown, we have 2 angles and 2 sides. But focusing on the rule that's going to allow us to use the 2 angles and 2 sides, they have to be the sides and the opposite angles. Okay, so over here, when we use the sine rule, we are going to use this angle with its opposite side. Okay, so we could call that angle A. And then the opposite side would be small a. Okay, then the other side that we have is B, is going to give us the opposite angle. So this angle here. Okay, so when we actually find this angle here, we are then going to have to figure out, okay, what is the third missing angle? That'll be easy enough once we have the other 2 angles though, because we know that the 3 angles in a triangle add up to 180 degrees. Okay, so we'll just be able to say that it's 180 degrees, subtract whatever A is, and subtract whatever B is. So we are going to use our sine rule then and find the opposite angles. Okay, we kind of expected that it was coming because we haven't used it yet. So our sine rule, so C part 1, I'm going to just do it over here. It's just nice to have a little bit more room. We also said that it is in one form in the log tables. Okay, so A over sine A, B over sine B, where it's the small letters on the top. Okay, and that is perfectly fine. we did say that the other way we could do it is to do that upside down. Okay, so the other way you can do it is to rearrange this to be like sine A over A is equal to sine B over B. And the easier way to do it is to have the unknown part on the top line. So actually, it'd probably be a bit easier for us to use this formula, even though if we use this formula, we would end up getting the same answer. So I'm going to use this formula here that's in grey, and I'm going to just sub in for my different things. Okay, so I'm going to have sine of my angle over the opposite side is equal to sine of another angle over the opposite side. So the A's first, my angle A is 42.7. And then my side A is 2.93. And then sine B is what we are looking for. We're looking for B. And then the side length there is 3. Okay, so we need to find what is B here. So we need to get this capital B on a side by itself, get rid of the 3 that's dividing by multiplying across by 3. So that I'm going to get 3 times sine 42.7 over 2.93. And that's what sine B is going to be equal to. Okay, I'm not actually looking for sine B, I'm looking for B by itself. So I am also going to have to do the inverse sine. Okay, so you can work it out now, you can work out the left side, or you can bring over the sine and say inverse sine of 3 times blah blah blah. Okay, I think at this point it'd be easier just to figure out what does the left hand side equal. So I'm saying 3 times sine 42.7 over, I forgot to close my bracket, over 2.93. Okay, so when I do that, I'm going to get 0.6943614367 is sine B. Okay, so let's get rid of the sine there by doing the inverse sine on the other side. Okay, so I'm getting the inverse sine, and again, just to allow the fact that I've rounded here, I'm actually in my calculator not going to type those decimals in. I'm going to say inverse sine of, and then I'm going to just use that answer button on my calculator so that I get 43.97635,379 degrees is what B is equal to. Okay, we are finding this other one, C, and we are going to be finding it to one place of decimals. So we're going to be rounding it to one decimal place. That means we can also round B to one decimal place. So B rounded to one decimal place is going to actually round up. So if we were to try and round this to one decimal place, it would actually end up being 44.0 degrees. Okay, so we don't need to focus on that too much for B. It's not our final answer. So I'm going to just round it to 44 here. Okay, if you are unsure, you could leave it with a few decimal places and then find C and then round it. Okay, we know now that C is going to be 180 degrees. We're taking away the 42.7 degrees, and we're going to take away the angle B, which we have just found is 44 degrees. Okay, so 180 minus 42.7 minus 44, and we end up with 93.3 degrees. Okay, and that's that one finished. The last part of this question says the ship is sailing at a speed of 23 kilometers per hour. Find, correct to the nearest minute, the time taking to sail from A to B. So they want this to the nearest minute. We are talking about distance, speed and time. So before I start anything, I'm going to write out my distance, speed, time triangle. Okay, so distance, speed and time. And it says they've given me the speed and they have said to sail from A to B, we know that distance. Okay, so the distance is 3 kilometers. Okay, they've also then told me the speed is 23 kilometers per hour. And then the thing that I need to find is how long. Okay, so how long is it to the nearest minute? So you can either change the speed here to kilometers per minute by dividing there by 60, or find it in hours, find the time in hours and then move it to minutes. Okay, so we are finding time, so cover over the t. Okay, and you see that time is distance divided by speed. So I'm just going to find the time in hours. Okay, so it's distance over speed. So I'm going to fill that in. So 3 kilometers over the 23 kilometers per hour. So that's going to give us, so 3 divided by 23 is some mad decimal. Okay, so it's actually easiest to just keep it as that. Okay, and we're going to be left with however many hours. So 3 over 23 hours. So to get hours into minutes, for example, to get from 1 hour to 60 minutes, I had to multiply by 60. So I'm going to multiply that then by 60. Okay, so think about just how you convert from 1 hour to minutes. We'd have to multiply the 1 by 60. Okay, not divide. So I'm going to multiply that answer there by 60. And I'm going to get 7.826 minutes. Okay, so to the nearest minute, then it is going to be 8 minutes. If I was asked for minutes and seconds, you would go to the button on your calculator, just underneath the square root, where it's like a degrees, and then a apostrophe, and then 2 apostrophes. Okay, if you click that button, it's going to show you exactly